Hi guys, so today I'm gonna talk about big numbers. 1 million is 1 followed by 6 zeros. So this number is a number of a price of a big house, and also it could be the number of a population of a city. And here's an example for 1 million. Uh, you get you if you buy like a big screen that's like about 720 pixels, 120 one 1280 times 720 equals about 1 million pixels. So a billion is 1 followed by 9 zeros. Yeah, if you want to count to 1 billion, maybe it take you about 32 years without taking a break if you count to 1 billion every second. 1 to 1 billion. Trillion equals 1 followed by 12 zeros. So if you want to count to 1 trillion, it will take you about 32,000 years. So 1 trillion is probably the biggest number in most people's mind. But of course, there is much bigger numbers than this number. Yes, and quadrillion is 1 followed by 15 zeros. And then a quintillion is 1 followed by 18 zeros. So, etc. And this number, 7.0 times to the 10 to the 13, is the number of dollars of the world's GDP. So 10 to the 16 is the number of ants on Earth. So that's 10 quadrillion ants. And 10 to the 18 is the number of grains of sand on Earth. That's 1 quintillion grains of sand. Can you imagine? That's a lot. And the number of stars in the observable universe is between 10 to the 22nd and 10 to the 24th stars. So the number of stars in the observable universe is bigger than the number of grains of sand on Earth. So can you imagine the number of stars in the observable universe? There are a lot of them, more than the grains of sand here on Earth. And then 10 to the 27, it's called 1 octillion, number of atoms of a human's body. This one is called 1 octillion. One octillion. That number 10 to the 27 is called 1 octillion. Yes, yeah, 10 to the 18 is 1 quintillion. Yeah, and then 10 to the 20 to the 21st equals sextillion. And then 10 to the 24 is 1 septillion. Then 10 to the 27 is 1 octillion. So 10 to the 50 is a number of atoms on Earth. So of course the number of atoms on Earth is a very huge number. Yeah, and 10 to the 57 is the number of atoms in the sun. And 2.4 times 10 to the 67 is the number of atoms in the Milky Way galaxy. Our galaxy contains a 2.4 times 10 to the 67 number of atoms, which is a very big number already. And then 10 to the 80 is the number of atoms in the observable universe. 10 to the 80 is the number of particles all over in the observable universe. And then then this number 10 to the 90 is number of grains of sand that can fit in the observable universe. So can you imagine now filling up everything with no space, just grains of sand? That will be 10 to the 90. Of course, that number is bigger than the numbers of atoms in the observable universe, because the atoms are there is not filled up everywhere, because most of the universe is just empty space. So now 10 to the 100 is called a Google. Then of course the company Google was named after this number, because this number was probably misspelled. It was misspelled, and then the company named it Google after this one. So this one was named in of 10 to the 100. So Google is way bigger than the number of atoms in it on the observable universe. So that's 10 to the 80. And then one more thing, 10 to the power 100. That equals a Googolplex. A Googolplex is followed by a Google zeros. Of course, a Google is here, 1 followed by 100 zeros, and then here is 1 followed by Google zeros. You cannot write this number down, because if you write down, then that paper will be bigger than the universe, bigger than the observable universe, and of course, even if you write down, each zero in each atom, you run out of particles, you run out of atoms in the universe, because the universe has only 10 to the 80 atoms, and that's 10 to the 80 smaller than a Google, 10 to the 100, and then this number contains more zeros than the atoms in the observable universe, and this number is a very big number, the biggest number yet, and maybe most mathematic of any number. So, but of course, this number is not the biggest number yet. There's much bigger numbers like Graham's number and so on. There's much bigger numbers than the Googolplex. So if our universe was about, if the observable universe is a Googolplex meters across, you can actually find an exact copy of yourself. So I find this very mind-blowing. Of course, if our observable universe was like very big, like a Googolplex meters across, we can actually find a copy of yourself. You can find a copy of yourself if this universe was very big enough like that. So forget about aliens. So if we find a copy of ourselves, it will be very mind-blowing that this number is very big, much more than the atoms in the observable universe. So there you have it. Right now, there's much bigger numbers than this number, like Graham's number and other. But I'll talk about that later. So I'll see you in the next video. Have a nice day.